Good day, ladies and gentlemen. This is Sarel van Grennen, aka Mr. VG, and man, what an amazing day! Because today we are specifically going to look at similarity. Now, similarity is not something that you are going to use often again in grade 10 or 11, but wait till grade 12, then you do a whole chapter just on similarity. So please, even though you might not use it, keep it in the back of your mind for specifically looking at grade 12 Euclidean geometry. So when we talk about similarity, similarity means two shapes that have the same shape, but not necessarily the same size. So they kind of look the same, but they're not necessarily the same size. Now, what I mean by same shape, it is like these two bicycles. For a moment, I forgot the word for bicycle. Oh my goodness. What it means if there's a constant or if there's a common ratio, it means the left, to go from the small bike to the big bike, I had to multiply every single small little piece by the same number to get the size of the bigger bike. So in other words, I basically zoomed in. Think about taking a selfie and zooming it in and zooming it out. I still see it's you, but it's not the same size if I zoom in or out. So, how does it work with triangles? Well, with triangles, if two triangles are similar, like these two triangles, if triangle ABC is similar to triangle DEF, well, first of all, the angles are going to be the same, so the corresponding angles are the same, but also there exists a constant ratio, a common ratio, which in a nutshell means, let's say that was x and that was 2x. That means that I multiply everything on the left by 2 to go to the right. So if that is y, then that must be 2y. But what if this one was like 4z? Well, then this side would be 2z because it has to be a half. So there's a constant ratio that exists. Now, we're not going to spend much time again on it in grade 9, but grade 12, oh, it's going to come back big time. So let's look at an example. In this specific example, it says you are given the following sketch with NO being parallel to LM. Prove that triangle KNO is similar to triangle KLM. There's two main ways of proving similarity. Either by going 3 pairs of corresponding angles that are equal, or the sides must be in a ratio to one another. Now, I'm not going to look at sides being in ratio because I don't have nearly enough info about the length of the sides, but I'm going to try and look at the angle. So let's go back to the information that was given. The first bit of information tells me that I've got parallel lines. Therefore, I can look at F, U, and N. I'm going to specifically look at an F. Why? Because if you look at it carefully, let me just get my highlighter out here. If I look at this, there's my parallel sides, there's an F there, or if I look from the other way, there's an F there. So I'm going to start my sum by going basic recipe. In triangle this and triangle that, 1, 2, 3. First of all, angle N1 is equal to L, because of corresponding angles, and NO is parallel to LM. Next up, angle O1 is equal to angle M, also corresponding angles. Now, last but not least, I need that third pair. That third pair I can actually find because angle K lies in both triangles. How do I know that? Let's think about coloring in the small one, coloring in the big one. You see angle K is colored in twice. So that means that triangle KNO is similar to triangle KLM because of angle, angle, angle. Now we get to the second part of our question. Now the second part of our question tells us that if Kn is equal to 5 and NO is X, KO is 8, OM is Y, if KL is 10 and LM is 18, determine the values of X and Y. Now, whoa, sure. I'm actually going to split my triangle up into those two parts, KNO and KLM. I just find it works better if I do that for myself. Once I've split them up, I'm going to write in the information on the sketch. Okay, look at that KM, what I did there. I put that O there, and I kind of went KO is 8 and OM is Y. You'll find out in a little while why I do that. So now this means there must exist a common ratio. So whatever I times 5 by to get to 10, I've got to do the same to go from 8 to that side, as well as from X to that side. Now you can then maybe quickly spot the ratio, but I'm going to write it out formally. So I'm going to start by saying, well, KL over KN is the same as LM over NO. In other words, the large triangle side over the small one must be the same as the other large triangle side over the small triangle side, which is just exactly saying that there's a constant ratio. If I substitute in, I get 10 over 5 is 18 over x, and therefore x must be 9. Now you might come and say, sure, so do I really have to write that nonsense? Well, grade 9, I'm telling you now, teachers might still forgive you. You know what, if you just say, oh, x is 9 because of similar, the triangles are similar. But when you get to grade 12, oh my goodness, they want you to write this out. Okay? So it's kind of nice to get used to it now. So the ratio between KL and KN must be the same as the ratio between LM and ON. Next up, I'm going to go and try and calculate that Y. But that Y is actually a part of Km. So I'm going to say that KL over Kn is now that. 10 over 5 equal to y plus 8 over 8. And I'm going to solve this by saying that 10 over 5 is 2. Multiply both sides by 8. So in other words, y must be 8. Wasn't there an easier way? Let's go back to my previous slide and see. Well, actually there was. Let me explain what would be the easier way to do this. If I look at Km, it must be twice the size as Ko. So in other words, Km must be 16. So if Ko is 8, then y must also be 8. So really that simple? Yes, it is that simple. But you've just got to be able to explain that this is because the sides are in proportion. So you would have to write that km is 16 and give a reason why, therefore y is 8. So please just be careful, grade 9s, of just throwing away all of the reasonings and things. You still have to give reasoning. And the reasoning is that the triangles are similar. So have a beautiful and amazing rest of your day. I'm look forward to the next video. I'm going to just practice some more geometry, just some basic quadrilaterals and how it could be asked. So have a gorgeous and amazing rest of your day. This is Sarah van Ginnen, aka Mr. VSG, and I am signing out. Cheers.